Today we are going to continue with our solving, but what's going to happen in most cases here is we're not going to get a base that can be converted. So what I mean is you can't use the same base. So if you look at over here in number 1, it says 5 to the x equals 76. And we all know that 5 squared is 25, 5 to the third is 125. Nothing gets you 76. So what we do is if you look, see it says using logs, we're going to apply log to both sides of this equation. So we're going to go log of 5 to the x equals log of 76. And then what happens here is the x is going to go in front. Okay, that's one of the power of the properties here. So x log of 5 equals log of 76. And then we divide by log of 5. And if everything has been making sense, here's your change of base formula. So we need things to change. We need to find the answer. So log of 76 divided by log of 5 in a calculator. So log of 76, close a parenthesis or arrow out, divided by the log of 5. And you'll get 2.69, which will round to 2.7. All right. Over here, you'll notice it says 4 to the x minus 5 equals 2 in number 2. So we have to add the 5 first. You can't take anything to a base and an exponent unless it's all by itself. So it always has to have a base and an exponent by itself. Now, we're going to apply log to this side, both sides, and move the x in front. So that's x log of 4 equals log of 8. And then we divide by log of 4, both sides. And, no, it was blue, sorry. Then that's x equals log of 8 divided by log of 4 is 1.5 in a calculator. You can do that yourself and see that it is 1.5. If you wanted to, if anybody caught it, you could have converted these to same bases, right? You could have converted these two to same bases to be base 2. But if you didn't catch it, then you have another way to solve it. And that's kind of the point here, is to make sure and see that we have different ways to solve different problems, no matter even if we learned something different a day ago, or 2 days ago, or a week ago. All right? Okay. Let's move on to these two. These a little more complicated here. This here has 3 times 2 to the x, so we have to divide by 3. We get 2 to the x equals 9. And then we apply log to both sides, remembering to move the exponent in front. So log of 2, equals log of 9. And then, of course, we divide by log of 2 to both sides. And we get x equals, and I'll go to my calculator again to show you, log of 9 divided by log of 2 gives you 0.28. Let's call it 0.29. Oh, I times it. I'm sorry. I wonder why I got the answer wrong. Sorry about that. Log of 9 and then divided by. Sorry, I put times accidentally. Let's try that again. Sorry, guys. All right, so that's 3.2. Sorry, everybody. 3.2. Wonder why it was small. Okay. All right. So over here, for the last one, lots of stuff going on, if you notice. Lots of stuff. But we need, I'll go in green here, this to be by itself before we can apply log. So everything around it's got to go. All right. So we have to subtract the 13 first. You get 6 times 0.02 to the negative 5x, we'll take care of that later, equals 2. And then we divide by 6, both sides, and you get 0.2 to the negative 5x equals, we'll call this 1/3. I wouldn't really make it a decimal if I were you. All right, now we're going to have to apply log to both sides, moving this negative 5x to the outside. So negative 5x. Sorry, let me erase that. It's messy. Negative 5x log of 0.2 equals log of 1/3. Then we divide by log of 0.2. Okay, sorry for the runoff here. Negative 5x equals, let me go over here, show you what to do, log of 1 over 3 divided by the log of 0.2, and we get 0.683, that's fine, 0.68, all right, 0.68, and all you gotta do is divide by negative 5. X equals, just go in here and divide by negative 5, and I get negative 0.13 or 0.14. Negative 0.14. Negative 0.14. And that's it. Okay? Very similar to solving normal algebraic expressions, multi-step, except now at the end, when you get a base and an exponent, you got to apply log to both sides.